learning partial fractions. Let us see now what do we mean by these partial fractions. But trust me students, you are going to love this chapter because very easy. You are sure to get the full 5 marks in your exam. There is only one question for 5 marks and also it is a very small chapter. Let us begin right away. Now if I give you two fractions, two simple fractions of the form, let me say 2 by x plus 1 plus 3 by x plus 2. These are two simple fractions and now I am going to add these two fractions. If I add these two fractions, how do we add fractions? Taking the LCM, you all know this. So we will quickly take the LCM and this is what we get. The LCM is x plus 1 and x plus 2 and here in the numerator 2 into x plus 2 plus 3 into x plus 1. If I quickly expand this, what will I get? 2x plus 4 plus 3x plus 3 divided by x plus 1 into x plus 2 and this will give me equal to 5x plus 7 divided by x plus 1 into x plus 2. Now look at the term or the answer that I have got. I took two simple fractions, added them and I got this term. This term is called as a rational function or a rational fraction. There is one polynomial in the numerator and there is another polynomial in the denominator. One polynomial divided by another polynomial is called as a rational function or a rational fraction. These two fractions are called as, they are simple fractions, they are also called as partial fractions. What we are dealing in this chapter is, this is not what you are going to deal in this chapter surely. You will not be given these two. If you are given this rational fraction, that means if you are given 5x plus 7 divided by x plus 1 into x plus 2. Now the question is, this rational fraction, how will I express this as sum of two fractions? How will I express this as sum of two simple partial fractions? So the process of resolving a rational fraction into sum of simple or partial fractions is what we are going to learn in this chapter and it is called as resolving into partial fractions. So the only sum that you will have in this chapter is resolving into partial fractions. Before I start this topic, I would like to explain to you a few concepts. Let us now learn what is a polynomial function. Just look at the definition of a polynomial function. An expression which is written in the form a0 x to the power n plus a1 x to the power n minus 1, a2 x to the power n minus 2. Notice here the power of x is going on decreasing and last you get a constant term. What is important here is this first term should not be equal to 0. Rest all a1, a2 are constants, some of them could be 0. Then such a type of an expression is called as a polynomial of the variable x of degree n. Don't get frightened with this definition of polynomial. Just remember in your mind any equation, the normal equations which you are so familiar with, they are, and the variable is x and hence it is called as a polynomial of x. How do I calculate now the degree? How did I say its degree is n? All that you have to see is the highest power of the variable. In this case, since the variable is x, the highest power of x is n, and that's why we said the condition a n should not be equal to 0. I'm sorry, it's not an, it's A0. A0 should not be equal to 0. First, let us learn what is the definition of a polynomial function. What is a polynomial function is written here. Let us just read it. An expression of the form, look at this carefully, A0 x to the power n, A1 x to the power n minus 1, A2 x to the power n minus 2 goes on till An, and the condition is A0 should not be equal to 0, this first term should not be equal to 0, and the remaining A1, A2, An are constants and some of them could be 0 also. Such an expression is called as a polynomial of x in degree n. The variable here is x and that's why it's called as a polynomial of x. Don't get frightened with this definition. Let me tell you students, you are very familiar with the polynomial. All the equations involving x which you are so used to, that is nothing but a polynomial. Probably you have not called it as a polynomial, that's all. What do we mean by degree n? How did I get it as degree n? Now degree of a polynomial is nothing but the highest power of x. So among all the powers of x, the highest power of x is n. That's why we said A0 should not be 0. If it was 0, then the highest power would not be n. So the highest power of x, that is n here, is called as degree of a polynomial. Let me take an example. So let us just write a few examples of polynomials. Example 1, 7x cubed minus 3x squared plus 7 is equal to 0. This is a polynomial where the variable is x and highest power of x is 3. Therefore, this is a polynomial of degree 3. So, example of a polynomial of degree 3. Same way, I'll take another example. You are used to writing quadratic equations like this. In this, the variable is x and the highest power of x is 2. So, the degree of this polynomial is, the degree is 2. So, this is how we define. Supposing you only have a constant, let me say 7, then we say its degree is 0. You can always write 7 as 7x to the power 0. So, this is about polynomial and its degree. The next concept that we are going to learn is rational function or a rational fraction. Let us quickly read the definition. If f of x and g of x are two polynomials, we already saw what is a polynomial. So, if f of x and g of x are two polynomials in x, then f of x divided by g of x, where one condition, denominator should not be 0, this is always there when division comes, g of x is not equal to 0, is called as a rational fraction or a rational function. So, a rational fraction is nothing but ratio of two polynomials, one polynomial divided by another polynomial with the condition denominator is not equal to 0. Again, let us just see one or two examples for rational fractions we already saw in the beginning. So, let us write some example. So, example, let me write 1, example 1, x square plus 2x plus 3 divided by x square plus 4x plus 7. You have one polynomial divided by another polynomial and hence it is called as a rational fraction. Another example, 7x cubed minus 3x squared plus 2 by x plus 5. This is also an example of a rational fraction, one polynomial divided by another polynomial. We just learned what is a rational fraction. Now this rational fraction has two parts. One is a proper rational fraction and the other one is improper rational fraction. So two types of rational fraction, one is proper rational fraction and the other one is improper rational fraction. So what does this mean? You know, you are already familiar with numbers, you have learned fractions, you had fractions like this 2 by 3 or let me say 5 by 3. When you look at this, you will immediately tell me this is a proper fraction, and you will look at this and you will tell me that it is an improper fraction. So why did you say proper fraction? Numerator was less than the denominator and this was improper because numerator was greater than the denominator. Same logic, let us apply to functions. When we have a rational fraction, how do I find out whether a rational fraction is proper rational fraction? So if it has to be a proper rational fraction, the condition is, now I have to look at these two. When it is numbers, you can directly compare the numbers and say numerator is less than the denominator. But when it is equations, how can you say one equation is less than the other equation? You cannot say, but what you can compare is the degree of the equation. So, a proper rational fraction means the degree of f of x should be less than the degree of g of x. So just see here, rational fraction is f of x by g of x, degree of the equation in the numerator. If it is less than the degree of the equation in the denominator, then such a rational fraction is called as proper rational fraction. Now come to next one, improper. I am sure you would have guessed now what is the definition. Degree of f of x will be, please note this, will be greater than or equal to, please note this, even if it is equal to, if the degree of the numerator is greater than or equal to the degree of the denominator, then it is called as an improper rational fraction. So I hope you got this concept. I'll just repeat it quickly. Rational fraction of the form f of x by g of x can be divided into two parts, proper rational fraction and improper rational fraction. So when do I say it is proper rational fraction? Degree of the numerator is strictly less than degree of the denominator. When do we call this as an improper rational fraction? Degree of the numerator is greater than or equal to the degree of the denominator. Just look at these three examples and let us try to see whether they are proper fractions or whether they are improper fractions. So see the first example, x cube plus x square plus 7 by x square plus 2x minus 1. What is degree of the numerator? Degree of the numerator, highest power of x is 3. So the degree of the numerator is equal to 3. Now look at the denominator, highest power of x is 2. So I can conclude that the degree of the denominator is equal to 2. What do we notice here? Degree of the numerator is greater than the degree of the denominator, and hence we can conclude that this is an improper fraction. Reason? 3 is greater than 2. Now come to the second example. Look at the degree of the numerator, highest power of x is 2. So here again I can say that the degree of the numerator is equal to 2, and again look at the denominator, highest power of x. Highest power of x is 2, right? So we can say that the degree of the denominator is equal to 2. What do you notice here? Degree of the numerator is equal to the degree of the denominator, and even if it is equal to, it comes to the category of improper. So again I conclude that this is an improper rational fraction. Improper rational fraction, this is also improper. Now we will come to the next example. Look at the degree of the numerator. Here degree of the numerator is 1. Highest power of x is 1. So degree of the numerator is 1. Denominator, highest power of x is 2. So the same concept, now let us quickly write this. Degree of the denominator is equal to 2, and now you notice degree of the numerator, yes, it is less than the degree of the denominator, and immediately we conclude that this is a proper fraction. The next concept is, just read what is written on the board. This is an important concept when we are dealing with the problems of resolving into partial fraction. An improper rational fraction can always be expressed as sum of a polynomial and a proper rational fraction. Please note this, an improper fraction can always be expressed as the sum of polynomial and a proper rational fraction. Relate this to numbers. If I had an improper fraction with numbers, let me see, I have 7 by 5. Now 7 by 5 is very simple. You know how to divide it. You have also learned this improper fraction, how to convert it to a mixed fraction. So 5 goes once and the remainder is 2. You are used to writing like this. That means I can write 7 by 5 as 1 plus 2 by 5. That means you know in numbers that an improper fraction can always be written as a whole number plus a proper fraction. Now same thing, relate it to fractions involving polynomials. This was involving numbers. Now when I come to polynomials, what happens is, if I have an improper fraction, I can write it as, here it was whole number, there I can write it as some other polynomial, let me say t of x plus a proper fraction. And when I write the proper fraction, please see this example, the denominator remains the same. What you are writing here is the remainder divided by denominator. So you can write it as some other polynomial divided by denominator will be the same. If this is an improper fraction, you can always write it as polynomial plus a proper fraction. So this is improper and this is proper. If you don't like me explaining it in terms of x, I will explain it with the help of an example. I am sure you will understand it better when explained with an example. Here minus 5x plus 1. Look at the degree of the numerator. Degree means highest power of x, and yes, the highest power of x is 2. Look at the denominator. What is the highest power of x? Again, highest power of x is 2. Degree of the numerator is 2, denominator is 2. If they are equal, what do we conclude? Improper fraction. So yes, this is an improper fraction. Now I need to explain to you that this improper fraction can be written in the form of a polynomial plus a proper fraction. How do I do this? You go for division. You divide the two polynomials. It's not numbers now, it is equations or polynomials. But I am sure you have all learned how to divide two polynomials. So let us go for the division method. So if I have to divide this, relate in your mind division to numbers. The logic is the same, only the number has changed to the form of an equation, but the basic logic is the same. So I need to divide numerator by the denominator. So I'll write like this, numerator divided by denominator. Take care to see that it is in order. The highest power, if it is a quadrant x square, then x, then the number. So if it is not in order, when you divide, you need to arrange it in order. This is nice for us, it's already in order, nothing to do, directly to go for division. Now how do we divide equations? You take the first term of the numerator and divide it by the first term of the denominator. So actually you have to see x square goes in x square how many times. But if that is confusing, you can just remember it this way. First term of the numerator, so think in your mind, first term of the numerator is x square divided by first term of the denominator. So x square divided by x square, it goes once. So you know it goes once. So this is what you are doing rough work, or you are slowly doing this calculation in your mind. So you know it goes once. Then what should you do? You should multiply 1 to all these terms. Now since it is 1, it's very easy for us to multiply. We get back the same term, x square minus 5x plus 6. Then we know that we need to subtract these two. And when I subtract, the first term should get cancelled. If it does not get cancelled, I have gone wrong in my calculation. So please note this. This has to get cancelled when you subtract. So when we subtract, what should we do? We should change the signs. So this was plus will become minus, minus will become plus, and this plus will become minus. Now let us subtract. X square minus x square, it got cancelled, good. There is no x term here, but there is an x term here. So it's like 0 plus 5x, so it will be 5x. Then compare the constants here, 1 and here minus 6. Please note, 1 minus 6 is minus 5. The division may be over or it may not be over, I need to check. Again go for the same concept. First term divided by the first term here. First term is 5x and the first term here is x square. Now you know x is less than, the degree of x is less than the degree of x square. So you know it is a proper fraction. That means this degree is less than this. So our division is over. This should be the this should be the remainder. Now how do I write this polynomial, this fraction? X square plus 1 divided by x square minus 5x plus 6 is equal to, think of my example in your mind, think of this example which I told, 7 by 5, I wrote it as 1 plus 2 by 5. What was 1? 7 when I divide by 5 goes once, the quotient or the answer that you get. This is the remainder and this is the denominator. So follow the same pattern. You have to write it as answer plus, so think in your mind, this is what you have to think in your mind. You have to write it as, answer plus remainder divided by denominator. So think in your mind like this. Whatever answer that is quotient plus remainder divided by denominator. So this is going to be the pattern to write. The answer that I got was 1, the quotient that I got was 1, 1 plus, what was the remainder? Remainder is 5x minus 5 divided by denominator. So the denominator is there here, x square minus 5x plus 6. So this is what not to be written in the exam, that is just for us to keep in our mind. So I'll slowly erase this. So now you see this improper fraction, we are able to write it as polynomial plus a proper fraction. If you have understood all these concepts, then you are all set to work out the problems on resolving into partial fractions. So let us directly go now to resolving into partial fractions. Now just note here, see the heading that I have written, resolving proper fraction. Please note this, resolving proper fraction. Only a proper fraction can be resolved into partial fractions. Now what happens if I get an improper fraction then? We just learned you can write the improper fraction as polynomial plus a proper fraction. Then that proper fraction you will resolve into partial fractions. So note this, keep this in mind, very, very important concept, that if I have to resolve into partial fractions, the condition is it should be a proper fraction. If it is improper, I need to divide and convert. So that we will see when we work out the problems. Now let us see how to resolve into partial fraction, what are the rules. Now in the syllabus that we have to learn only two types, type 1 and type 2. Now type 1 is when the denominator consists of non-repeated linear factors. So for example, if you have a term like x plus 2 by x plus 3 into x minus 2, denominator is having two linear factors and the linear factors are not repeated. So then it belongs to the type 1 non-repeated linear factors. Then you have another category when the denominator consists of repeated linear factors. So let me take an example for this one. 9 by x minus 2 the whole square x minus 3. If you look at this example here, the denominator has one linear factor x minus 3. It has another linear factor x minus 2 and x minus 2 is there twice. X minus 2 the whole square means x minus 2 into x minus 2, that means x minus 2 is repeated. So this category of sums will fall to type 2 repeated factors and this category will fall for type 1 non-repeated factors. We shall now learn how to work out type 1 problems. I will explain directly with the help of an example. So see the sum, resolve x by x plus 1 into x minus 4 into partial fractions. First thing is check whether it is a proper fraction. Degree of the numerator is 1 and degree of the denominator, please note it should be in the expanded form. When you multiply x into x, you will get x square. So the highest power of x will be 2 and here it is 1. So you know that x by x plus 1 x minus 4 is a proper fraction. If this is a proper fraction, now we see how to resolve this into partial fractions. Now this fraction x by x plus 1 x minus 4, I know I have to write it as sum of partial fractions or simple fractions. Look at the denominator. It has how many factors? It has 2 factors. So write one denominator as the first linear factor, that is x plus 1, and the second one, so I need it as sum, so I will write plus and write the second denominator as the next factor x minus 4. If there was a third factor, then I would have written plus and written the third factor. Now there are only 2 factors. Now I want to get, this is equivalent to sum of 2 fractions. What are those 2 fractions? So basically I need to know what will be the numerator. I know 100% that these two are proper fractions. If they have to be proper fractions, then the only possibility is I cannot have an x term in the numerator, I can only have a constant. I don't know what is that constant, and in maths whenever we don't know, we assign it some names. So since x is already there, I will take the name for the constants as a and b. So this numerator I don't know, so I have written it as a. This numerator also I don't know, so I have written as b. So now my only task is how to find a and how to find b, so that when I add these two, it will be equal to this fraction only. That's also important. So how to find what is a and what is b? Let us do this method. Now the right hand side, let me take the LCM on the right hand side. If I take the LCM on the right hand side, it will be a into x minus 4, a into x minus 4 plus b into x plus 1 divided by x plus 1 x minus 4. Look at this, what we have got on the left hand side is x by x plus 1 x minus 4. This is left hand side equal to this on the right hand side. Now what do you notice here? The denominator of the left hand side and the denominator on the right hand side are the same. Both these are equal to each other. That means numerator of the left hand side should be equal to numerator on the right hand side. So quickly write what is the numerator on the left hand side. So I'll just write here for you to understand. What I'm doing is I'm equating the numerators. When I equate the numerators, what I am getting is left hand side is x and right hand side is a into x minus 4 plus b into x plus 1. Let's write this as equation 1. Now from here again, my work is not over. I need to get what is a and what is b. This equation is true for all values of x. Now I know that when there are two variables to find out, I need to have two equations. How do I get these two equations involving a and b? So to get the equations involving a and b, we substitute some random values for x. You can substitute any value for x, but substitute such values of x so that life will be easier and solving becomes easier. So what is that easiest value of x you can substitute so that you can easily calculate the value of a and b? The easiest value that you can substitute is, look at these two factors. Now what value of x will make this x plus 1 equal to 0? So this is what you should think in your mind. I'll write it at this side. Directly you can calculate without writing. So I have to think, what will make x plus 1 0? Which value of x will make x plus 1 0? X is equal to minus 1. So one value for x is minus 1. Next, look at the next factor. What will make x minus 4 0? Again, this is what you're thinking in your mind. Next, think in your mind, what will make x minus 4 0? What value of x? When you put x is equal to 4. So now you got those two values of x. One was minus 1 and the other one was 4, which will make the two factors 0. So these are the two simplest values of x that I am going to substitute. But please note, you could take any value of x, but these will be the easiest for you. So let me substitute now in equation 1. First I will substitute x is equal to minus 1. So when I substitute x is equal to minus 1, in the full equation, wherever there is x, replace it by minus 1. I will repeat. In this full equation 1, wherever there is x, replace it by minus 1. So what happens here? Left hand side, if I replace x by minus 1 is equal to a into minus 1 minus 4 plus b into minus 1 plus 1. Look at this, minus 1 plus 1 is 0, 0 into b is 0, b gets eliminated. That is why that was a nice option to substitute. B got eliminated directly. So you get an equation with only one variable. That means you can directly find what is the value of A. Beautiful, isn't it? Yes. So this is minus 1 is equal to minus 1 minus 4 is minus 5. Be careful with your calculations. A into minus 5, and this one when you substitute, be careful now. A is here. Minus 5 should come this side. So minus 5 should come to the denominator. Be careful with this one. So minus 1 divided by minus 5 is equal to A, which implies A is equal to 1 by 5. So I got one value of A, and that is A is equal to 1 by 5. Now I want to substitute another value for x. What was that other value? Other factor, x minus 4. Think in your mind, what will it make it 0? This is how you should think. X minus 4 is 0 means x should be equal to 4. So my next substitution is substituting x is equal to 4. Now if I substitute x is equal to 4, again in equation 1, wherever there is x, replace it by 4. All the x replaced by 4. Note this point. Now start here, left hand side, x is there, put x as 4. So you get 4 is equal to A into, yes, 4 minus 4, be very happy, it became 0, A got eliminated. Next one here, plus B into, in the place of x I should substitute 4. So it becomes 4 plus 1. This is gone, very nice. So you are left with 4 is equal to B into 5. Be careful, you want to get B. B will remain here, 5 will come this side, comes to the denominator. 4 by 5 is equal to B, or this implies B is equal to 4 by 5. So I got the value of A and I got the value of B. Please note here, I need to write the final answer. Common mistake you will make is, you will be so happy that you got the value of A and B, you will think the sum is over. No, it's not over. Please make this a habit to write the final answer. 1 mark is for writing the final answer. So therefore now, I need to write the final answer. Therefore, what was the question? X by x plus 1 into x minus 4 is equal to, I have to write it as partial fractions. What was A? A is 1 by 5. Write it carefully. For A, what was the denominator? Denominator was x plus 1. So this is 1 by 5 divided by x plus 1 plus. Next one is B. What is the value of B? 4 by 5. And what is the denominator for B? It is x minus 4. So it will be 4 by 5 divided by x minus 4. And yes, now the sum is complete. Question 2, 7x minus 1 divided by 1 minus 2x, 1 minus 3x. Look at the denominator, you can see 2 linear factors which are not repeated. Also, first check whether it is a proper fraction. degree of the numerator is 1 and degree of the denominator is 2. So you know this is a proper fraction. So you know it's a proper fraction. It is non-repeated linear factors. So the method is 7x minus 1 by 1 minus 2x 1 minus 3x equal to, write the first factor 1 minus 2x plus write the second factor 1 minus 3x. Because they are linear, numerator will always be a constant. Let us give the names as A and B. So the next step is take the LCM. So when you take the LCM, what do we get? A into 1 minus 3x plus B into 1 minus 2x divided by 1 minus 2x into 1 minus 3x. What is the next step? Equating the numerators. So equate the numerators. When you equate the numerators, left hand side 7x minus 1 and right hand side is A into 1 minus 3x plus B into 1 minus 2x. Now this I write as equation 1. I need to substitute values for x in order to find the value of A and B. What is that value of x which will make it easy for calculation? Look at the first factor. 1 minus 2x. What will make 1 minus 2x 0? I know, little unpleasant, not like the previous example. Anytime you get confused, write it at one corner. Just write it at one corner and see. 1 minus 2x should be equal to 0. 1 is equal to 2x. Bring 2 this side. So x is equal to half. So now you know one value is, we'll write it somewhere at the corner for us to remember, x is equal to half. So this was one value, correct? Now the next one. What will make the next factor 0? What will make think? 1 minus 3x is equal to 0. What value? 1 equal to 3x, bring 3 this side, x is equal to 1 by 3. So now you know that I am going to substitute x is equal to half and x is equal to 1 by 3. So I will put this value also at the corner, x is equal to 1 by 3 and x is equal to half. So these are two values I am thinking in my mind. So this was all the calculations that I had to do in my mind or somewhere at the rough work. Okay, now let us proceed. I need to find A and B, so I will substitute values for x. So the first value that I am substituting is x is equal to half. So when I substitute x is equal to half, in equation 1, wherever there is x, replace all the x by 1 by 2. So here it is 7x minus 1. So 7 into 1 by 2 minus 1 equal to A into 1 minus 3. Instead of x I should write 1 by 2 plus, now I know when I put 1 by 2 this will become 0. You need not write if you want, but for practice 1 or 2 sums let us write. So b into 1 minus 2 into half. So you know that this is becoming 0 and b is getting cancelled as it is getting eliminated. So 7 by 2 minus 1 is equal to a into 1 minus 3 by 2. So let us see what answer we will get here. Take the LCM, 7 minus 2, this is 5 by 2 is equal to a into minus 1 by 2. Be careful with the calculations. 2 and 2 will get cancelled and you will get 5 is equal to minus a, but I want to get the value of a. So a is equal to minus 5. So this is one value. Next I will substitute. So this is one value, I will just write it properly. 5 is equal to minus a, which implies a is equal to minus 5. Now substitute next value. What is the next value which will make this factor 0? X is equal to 1 by 3, we have already calculated. So substitute x is equal to 1 by 3, where equation 1. How? Replace wherever there is x, replace all the x by 1 by 3. So this is how you should do it. So 7 into 1 by 3 minus 1 is equal to, now you know that a is getting eliminated. 1 minus 3 into 1 by 3, you know it's becoming 0, very nice. Next one, plus b into 1 minus 2 into 1 by 3. So let us see what we are getting now. This is 7 by 3 minus 1. When you take the LCM, you will get like this, and here, yes, this is becoming 0, no need to write. This is 1 minus 2/3, and that is 1/3. So 7 minus 3 is this, what you are getting here is 7 minus 3 is 4. 4 by 3 is equal to b by 3, or from there you are getting b is equal to 4. So now you got a is minus 5 and b is equal to 4. Remember, the sum is not over. I have to write the final answer. So the last step of writing the final answer. Therefore, 7x minus 1 by 1 minus 2x into 1 minus 3x is equal to, important, you should know what the answer is, a by 1 minus 2x. What was a? A is minus 5. So minus 5 by 1 minus 2x plus b. b should be the numerator for 1 minus 3x, and b is 4. So 4 by 1 minus 3x, and yes, now the sum is over. Question 3. 3x plus 1 by x square minus 6x plus 8. Again, first part is the same. Degree of the numerator 1, denominator is 2. Therefore, this is a proper fraction. Now, the factors are not repeated, but look at this. Look at this. This is not linear factors. This is a quadratic equation. Now, type 1 said denominator should be product of non-repeated linear factors, but this is quadratic. So now, can I factorize this and write it as product of linear factors? How to factorize this? I am sure you can do it directly, but then let me write it here for you. X square minus 6x plus 8. How do we factorize this one? So if I have to factorize this one, product should be 8 and the sum should be minus 6. So search for factors such that product should be 8 and the sum should be minus 6. So you know the factors are minus 4 and minus 2. So x square minus 4x minus 2x plus 8. Now in these two, x is common, x minus 4. Take these two factors, you know 2 is common, but you want to get x, so you have to take minus 2 outside. If I take minus 2 here, I get x. From here, if I take minus 2, I get minus 4. So this could be written as x minus 2 into x minus 4. So now you know that the denominator can be factorized into product of linear factors. So if it is given in this form, you first need to factorize the denominator. Now that we have factorized and we have We know that it is equal to x minus 2 into x minus 4. We will come back to the problem. 3x plus 1, I am not going to write the denominator like this, I am going to write it as x minus 2 and x minus 4. Now split this into partial fractions. You know you have to write this as, for each of the factor you will get one term. So here x minus 2 plus here it is x minus 4, for this one numerator a and for this one we write it as b. Then we take the LCM. When we take the LCM we get, this is equal to a into x minus 4 multiply plus b into multiply by this factor x minus 2 divided by x minus 2 into x minus 4. Denominators are the same, so equate the numerators. So equating the numerators, left hand side numerator is 3x plus 1 and the right hand side numerator is a into x minus 4 plus b into x minus 2. Write this as equation 1. Now I need to substitute. So the method is going to be the same throughout the chapter. Now what are the values? What will make x minus 2 0? Now I think you can guess it directly. X minus 2 is 0 means I should take x is equal to 2. If this factor has to become 0, I should take x is equal to 4. So the substitution, so first I will substitute x is equal to 2. So when I substitute x is equal to 2, what do I get? In the equation 1, wherever there is x, replace all the x by 2. So it is 3 into 2 plus 1 is equal to a into 2 minus 4 plus, yes, you know that this is becoming 0 and it is going to be eliminated, b is going to be eliminated. So now 3 into 2, 6 plus 1 is 7, a into 2 minus 4, 2 minus 4 is minus 2, next one has become 0, no need of writing. Now I need to get the value of a should stay here as it is, minus 2 when it comes this side should come to the denominator, be careful. 7 divided by minus 2 is equal to a, or this implies a is equal to minus 7 by 2. So I got one value, that's I got the value of a. Now I need to find what is b. So the next substitution, substitute x is equal to, now what should be the substitution for the next factor? Here to make this 0, x is equal to 4, right? X is equal to 4. How to substitute? Equation 1, wherever there is x, replace all the x by 4. So this becomes 3 into 4 plus 1 is equal to, here you know that this becomes 0 and gets eliminated, and the next one plus b into 4 minus 2, yes, right? Here this becomes 13, this is gone, a is gone, now only b is left, 4 minus 2 is 2, so 2 into b, but I want the value of b, so b should come this side, so from here I get 13 by 2 is equal to b, or I can say b is equal to 13 by 2. So I got a, I got b, not over, yes, now you remember sum is not over, I need to write the final answer. So the conclusion, what was the question? 3x plus 1 by, you could write this or you could write this, does not make a difference. You could write it in any way. X square minus 6x plus 8 is equal to, don't exchange the numerators. What is the numerator for x minus 2? It is a. And what is the value of A? Minus 7 by 2. Minus 7 by 2 divided by x minus 2 plus, what is the numerator for x minus 4? B, and B is 13 by 2 divided by x minus 4. Yes, we are done, and that is the answer.